All right. Today, welcome to the night class. We're doing 11.5 common logarithms. So, when something's common, what does that mean? It happens a lot, right? Okay. So, in our case, the log button on your calculator, we talked about this yesterday. What base is it? It's 10. That's a common logarithm, okay? Because most of the numbers we deal with are base 10, okay? So we're going to do that, but we're not going to use our calculator. They're going to give us, example 1 here, we're given that log of 7 equals 0.8451, and they want us to evaluate each logarithm using that and the properties that we've already learned, okay? So you start off with A here, the log of 7 million. Okay, well, I'm going to change 7 million to something I can use. I already know 7. What can I multiply 7 by to get 7 million? 1 million. So I'm going to change that to 7 times 1 million. Everybody with me so far? Okay, I now can, using my property, change this to 2 separate logs where I add them up. Okay, so this will be log of 7 times log, and I'm going to write this, rather than writing 1 million, I'm going to write it as 10 to the 6th power. Okay, these are real easy. You just count how many zeros there are. Okay, 1, 2, 3, 4, 5, 6. So that's 10 to the 6th power. Everybody with me so far? I can do this, and I put times here. What should I put? That's a mistake. I should have put a plus. Sorry. Okay? And now I can do this because I know log of 7. What was the log of 7? It told us up here 0.8451. So this is 0.8451 plus. And here's something we didn't talk about yesterday. When this base and this base is the same, they cancel each other out. And I'm left with what? 6. Because think about it. When the base is 10 here, you're asking what exponent do I take 10 to get 10 to the 6th? Well, 6. Okay, that's all right. Remember, if we were doing it like we did yesterday, that'd be 10 to the x power equals 10 to the 6th power, and so x equals 6. So basically, anytime these two bases are the same, those just cancel out. Is that making sense? Okay. And then you just add up those numbers. So 6 plus 0.8451 is 6.8451. Easy enough. Okay. Part B. 0.0007. What would that be? Very good. 7 times 0.0001. Okay? I can expand that to be log of 7 plus, because we're multiplying, log of 10 to the what? Negative 4. You got to move that decimal 1, 2, 3, 4. Okay? And then, same thing we just did. Log of 7 is still 0.8451 plus negative 4, because again, those cancel. Everybody with me on why they cancel? Okay? They only cancel if the bases are the same. If this had been log base 8 of 10 to the negative 4th, you can't do that. Okay? Negative 4 plus 0.8451 will be negative 3.1549. Okay? Everybody good on the first example? Beautiful. Example 2. These, you don't have any easier problems. Okay? What base are they? 10. So guess what you just get to do? Just put them in your calculator. Log. Okay? Make sure you put them in correctly. Let me go to my calculator. You do log, which is this button over here right next to the 7. Log of 5 5 times 2 to the 3rd power. Oops. Everybody see how I did that? And you hit enter, and you write your answer. 1.6021. I think they're rounding to 4 decimal places for the most part on your answers. Okay? 1.6021. All right? You try part B. Try putting that in your calculator. You'll need to put parentheses around the entire thing. When you do log, it'll automatically add, it'll open a parentheses. You just need to make sure you try to close it, okay? Say it one more time. 1.7794 is correct. Everybody good? All right. Example 3. Got 2 more examples here. The change of base formula. Many of calculators that you get from Walmart or wherever, they don't have that little special log base button that your calculator has where you can make the base whatever you want, okay? So, as long as you have a log button, you should be able to do any log using this change of base formula, okay? Now, this is the formula. It looks all like hard, for lack of a better word, or complicated. It's really not that complicated. All you get to do, if this is, what's my base in the original here? A, okay? If you don't like that base, if it's something that you don't want, okay, you can change it to something else. You just have to divide these two on top of each other, okay? So, in actual use, say your calculator doesn't have that little base, log base formula button. All it has is log. Well, that's no problem because we can change this. If all it has is log, make the bases what? 10. Now understand, can you make the bases anything you want to? Yeah, okay, they just have to be the same base, but most of the time you're going to want to make it a common logarithm, which is 10, okay? So this would just be log of 1043 divided by log of 9. And now you can put it in your just regular old calculator, okay? Put it in your calculator, round. You should get, if my calculations are correct, and this is the one where the book is incorrect, I believe. It says 3.1632, but when I put it in my calculator, I got 0 at the end there. Is that what you got? So I'm thinking it's a typo in the book, because if you keep looking, it's like 3.015, and I think they just put the 2. They rounded the 1 there to a 2, but they forgot about the 0. So anyway, that's what you should get, rounded to 4 decimal places. All right, easy enough. You only have to do this. I'm not saying you can't use the log base button. So just do this when it says use change of base. All you gotta do is show me this. That way I know that you know what the change of base is. Okay. Otherwise, you can always use that little change of base, the log base button. Okay, where you can make the base whatever you want. Everybody good? All right. Our last example, we are actually solving. Okay, we're actually solving an equation. What kind of equation is this? Say it louder. Exponential. How do you know it's exponential? Because the variable is a what? Exponent. If the variable is an exponent, it's exponential. Okay? So we want to get rid of that. Okay? So there's 2 ways we can do this. I'm going to show you both ways. Okay? The first way is the way I like to do it. And I'm going to go back here to this first example that we did. Oops, I went too far. Okay, so right here, we were talking about this. These bases, when they're the same, what do? They cancel, and you're just left with that. Everybody see that? Okay, so using that knowledge, if I wanted to get that 6x off, or that 3x off of the exponent, what could I do? I could make the basis. I could take the log of both sides, and what base I use depends on what base is there. Okay, what base is here? 6. So if I did the log base 6 of 6 to the 3x, whatever we do on one side, we have to what? Do to the other. The log base 6 of 81. This, what happens? It cancels, and I'm just left with 3x equals log base 6 of 81. And then one more step, we divide by what? 3. And you can put all that in your calculator. Okay? You can do the change of base formula if you would like, or you can just do the log base button. Okay? Let me see, what's the book? The book was right on this one. Yes, 0.8175. 0.8175. The book does not show you doing it that way. Okay, here's how the book shows you doing it. All right, you take the log, regular log, okay, of both sides. Everybody good with that so far? Okay, using our properties, because I can't cancel these right here. Okay, using the property though, what can I do with this exponent? I can move it to the front, which makes it 3x log of 6 equals log of 81. And now, if I want to get x by itself, I just divide everything that's with it. Okay, so I can divide by 3 log of 6, divide by 3 log of 6. Cancels, cancels, cancels. X equals 0.8175. Same answer. Okay? It's the same answer, really the same amount of work. It's just, to me, I just like canceling it out to begin with. Okay? All right? Now, this method, the second method, is better if you just have the regular log button without the log base button, okay? This one, if you have that log base where you can plug in any base you want, I would go with the first way. Does that make sense? Everybody good? All right, y'all want to do some of your homework problems? Is that okay? Oh. Caitlin, would you like to do some homework? Awesome.
The first one kind of confused me.
The first way?
Yes, sir.
Okay.
Yeah, I'm going to use second.
You're doing the same thing, because look, if I were, just to show you, if I were to do the change of base formula for this one,
Yes, sir.
I would have log of 81 divided by log of 6,
Yes,
and I still have the 3 down here. So I'm log of 81 divided by log of 6 with the 3 down here. See, it's the same, it's doing the same thing. This way is just quicker because, anytime you have a base right here and you want to get rid of it, do the log of that same base, and these will cancel.
Yes, sir.
And you just bring your 3x down, equals that, you just divide by 3.
Yes, sir.
Okay, so it's the same thing. Doesn't matter which way you do it. It's just like I said, this one, if you have that log base button, it's easier. This one, if you just have log, I would probably do it this way.
Yes, sir.
Okay? All right, so on your first 3 problems, we got 19, we just got the odds, okay? 19 through 51 odd on page 730. So we'll do a few of these. The directions tell us log of 4, tells us log of 9, and it tells us log of 12. So these are the numbers we're using. These aren't too bad except for 27, and I'll be honest, 27 kind of kicked my butt too. I had to break down and look at the answer manual. I hope you don't think less of me. Okay? Okay, thank you. That makes me feel good. All right, so I can change this one. What can I change that to? 4 times what? Times 100,000. 4 times 100,000. Well, I added a extra comma there. All right, so that would be log of 4 plus log of 10 to what power? 5th power. and we'll come look up here. Log of 4 is right there. It's 0.6021 plus these log, and the 10 does what? Cancels. 5.6021. Okay. 21. Log of 1.2. How could we take what they gave us? They gave us log of 4, log of 9, and log of 12. How could we make one of those into 1.2?
12 times negative 10 or something.
Very good. Close, not negative 10, but you're thinking the right way.
Negative 0.1? No, just 0.1.
It's just 0.1. Okay? Which is 10 to the negative 1 power. Very good. So log of 12 plus log of 10 to the negative 1 power. Again, in the directions, it told you what the log of 12 is. It's 1.0792 plus those cancel and make negative 1.
Hold up, Coach. That last step.
Here, as long as the bases are the same, those will cancel. Okay?
So even though it's an exponent, you use it like a regular number?
Yeah. Yeah, because again, this is the step we're skipping. Okay? So if I were to say log of 10 to the negative 1, okay, and I want to figure out what that equals, I would put equals x, right? So my base is 10 to the x power equals 10 to the negative 1. What's x equal? Negative 1. So that's the answer to log base 10 of 10 to the negative 1. It's negative 1. Okay? All right, 23. How do we get 36 from 4, 9, or 12? 9 and 4. 9 times 4, right? Log of 9 times 4. Well, that's going to equal the log of 9 plus the log of 4. And then you just plug those in from your directions. 0.9542 plus 0.6021. If you add those together, you get 1.5563. Okay. 25, getting a little more complicated. All right, I'll hold on for a second. Right here? Yes.
So you had it in the freezer?
No.
You had it in the fridge? And it was just cold. You took it out and you opened it and it froze.
Made a little slushy.
That doesn't make any sense.
Exactly.
It's really funny
Mr.
with the
Chester.
water bottle when you hit it on the table and it comes up from the bottom.
Pretty cool.
I don't
All right,
understand.
Mr. Chester
everybody good?
will have an explanation.
I know he will. Professor Chester's.
Professor Chester.
Because
Always.
You're looking at a computer with the answer on it right there. All you do is go click.
I know. It's a lot funner.
What do you mean, Clayton?
All right. 0.0048. He's talking about the Mr. Google.
Yeah, I
I
just
thought he meant this, and I was like,
No.
he's
Mr.
I was like, he's working this out, Clayton. What do you mean?
Mr. Google has all the answers. How do we change 0.0048 using 4, 9, and 12? 12 times 4 gives me what? 48, and then I just got to move that decimal. So 4 times 12 times, I'm going to go ahead and do the 10 to the what power would that be? Negative 4. Negative 4 power. And you can always quick stick them in your calculator just to make sure if you want to. 4 times 12 times 10 to the negative 4 power. 0.0048. So we're good. So that will equal, what do we get to do with all of these? What's our property? When you're multiplying, you get to add. So log of 4 plus log of 12 plus the log of 10 to the negative 4. I know this one from the directions. Log of 4 is 0.6021. The log of 12 from the directions is 1.0792 plus that log cancels and you're just left with negative 4. And you add those two up and subtract 4 and you should get negative 2.3187. Is that right? Okay. $27 was the mean one. Okay. Let's see. Y'all are smart.
Well,
Got Mr. Sullivan over there.
It's 18 times 100.
He can figure it out.
It's 18 times 100.
It is 18 times 100. The problem with that is we're using 4, 12, and 9, and it's hard to figure out.
It's 9 squared.
9 squared is 81.
Plus
9
10
squared is 81, not 18.
9 times 2 times 2.
There you go.
9 times 2 would be great,
The square
except
root of
we don't have 2.
the square root of the 12 times 4 is 48, and then you can subtract.
You are so close, Caitlin, and you don't even know you're so close. You're saying the square root of 9.
Yeah, times something 2.
It's 9 times what gives me 18?
6.
2. Look at what. 9 times 2 is 18. Look at what the numbers they gave us.
Square root of 4.
Is there any of those numbers that we could make into 2 doing like what you're talking about? Square root of 4. Okay? So, I didn't come up, like I said, I didn't waste. I took about 10 minutes trying to figure it out, and we just had to move on with class in first block, and so I was like, all right, I'm just going to look at the answer solution. So, and this is, but that's, you were on the right track. And I think I would have eventually got it. I just didn't want to waste time. So, this is going to be 9 times 4 to the 1/2 times 10 squared. Hayes, you had the 100 part right.
Yes, sir.
All right, 10 squared. So that will be log of 9 plus log of 4 to the 1/2 plus log of 10 squared. Log of 9 is 0.9542 plus. Now, this one. Where can we move that exponent?
To the front.
We can move it to the front. So this is 1/2 log of 4. Okay. What is log of 4? 0.6021 plus 2. And you can just add all that up. You should get 3.2553.
Well, it's really simple when you do it like that.
It is. And again, all of these really problems are making you use are your making sure you know your properties, okay? In real life, you're just going to stick that in your calculator because it's base 10 and everything. You just stick it in your calculator and it's going to shoot out the answer. So these are just making you practice using your properties. Like you need to know that, hey, I can move that 1/2 to the front there, okay? I can make this multiplying, make them into addition, okay? Yeah, we moved the 1/2 to the front. Do it now?
I just plugged log 4 to the 1/2 there. I should get the same answer as if you moved to the front there, right?
Yes. But, okay, you're using the whole thing on the calculator?
Yeah.
Okay, here's why it's not working. Because
I was like,
those 3 that they gave us, they rounded them.
Okay.
So yours is not rounded, so it's going to be off just a little. It should be close.
0.2552.
Yeah, okay, I was about to say, it should be really, really close. But it's going to be off a little bit because we're using rounded answers and your calculator's using the real thing, the whole thing. Does that make sense?
Yes.
Okay. Everybody good on 27? Yes, ma'am. Oh, okay. Moving on to the next three, 31, 29, 31, and 33. They are all simply calculator problems, okay? Anti-log, we didn't really go over them in the lesson because they're really easy. First, to do log, you just stick it in your calculator, okay? So
I know how to do that.
gotcha. So 29 is log of 894.3. You just put that in your calculator. You should get 2.9515. The other anti-log, okay, it's like, it says anti-log. It's like the inverse log, and every other inverse you've ever had to do on your calculator, what do you have to hit first? Second. So you just hit the little blue second button first, then hit log, then type in your number, and it spits out the answer, okay? I'm going to give y'all just a few seconds to put those in your calculator and tell me what you get and see if we get them right. Yep. It changes it to 10 to some power. Yep.
10.008. 2.008.
Should be 1.
It says 2. I mean 1. I don't know. No, I got 2. Yeah.
No. Point.
Yeah, I got 2.007. I got 2.0078.
And you round that 7 to an 8.
Here's what's in the book, and everything's right. It's just a matter of what you're rounding to. The book rounds for some reason to the nearest hundredth on this
So
one.
it's 2.00.
So they put 2.001. But I don't know, and it frustrates me too. They'll round to one number on some problems and a different number on another problem. So if you put 2.0008, we're good there too. Okay, that was fine. 33, again, this is what the book has. They go back to doing 4 decimals. 2.1745 is what they have. Is that what y'all got? Awesome. I don't know why 31's any different. I don't know why they made it the third decimal place. I don't know. Yeah, just stick them in. Everybody good?
Oh, 1 second.
No, you shouldn't need a lot of space. Like two lines tops. Starting with 35, these are the ones, if you have that special calculator that has the log base button where you can make the base anything, you can use that. However, the directions say use the change of base formula, so I want us to use the change of base formula, okay? You literally, showing your work just shows me that you know what the change of base formula is. So I would change this to log of what? What goes on top? 625 over the log of 5. And then you just stick that in your calculator. Okay? Please don't, see, a lot of people forget to do the log on the bottom. Okay? Don't be those people. Okay? You have to have log on top and bottom. And when you put that in your calculator, you should get a big grand 4. 4.
You scared me for a second when you said
Big grand. 37. Log base 7 of 4. Again, show that you know the change of base formula. So we're going to have log of what? 4 divided by the log of 7. And you stick that in your calculator.
Dude, I can't spell log right.
It's tough.
I keep putting LGO for some reason.
You do LGO, LAG, lag, you know.
I don't know what's going on.
GOL. Gall. We're in the South, you know, golly, you know, GOL, gall. 39, last one of these. Log base 1/2 of 15. That will be the log of 15 divided by the log of 1/2. And again, you just stick it in your calculator. You should get negative 3.9069. Everybody good on those? All right. $41. 5 to the x power equals 4 to the x minus 3. X plus 3, excuse me. All right. So this is where knowing both methods that I showed you earlier comes in handy, because we can't just, remember, whatever we do to one side, we have to do the other. So if I wanted to get rid of that 5, I'd have to do log base 5, right? Well, the log base 5 of 4 wouldn't get rid of it, okay? So I'm going to have to just pick a regular log, do common log, okay? So I'm just going to do the log of both sides. Log of 5 to the x equals log of 4 to the x plus 3. And we have to start using our properties. Man, that one question, that one example was a lot easier than this one. I hate it when they do that too. All right. What's our properties? We need those exponents not being exponents, because we're to get it, figure out x, we need to get that x where it's not an exponent anymore. So where can we move it? We move it to the front. That one can come here. So we get x log of 5, and this whole thing can come to the front. So that's x plus 3 times the log of 4. Don't forget your parentheses. I'm going to go kind of slow because it's a lot to take in. Have I blown anybody's mind yet? Okay. All it is from here is trying to get your x's on one side and getting the x by itself. Okay. So to do that, I have to distribute here. Okay. So that will be x log of 5 equals x log of 4 plus 3 log of 4. All right. Everybody good? We need to get what together? The x's. So I need to move which thing? How? Subtracting it over. Minus x log of 4 minus x log of 4. That does not equal log of 1. Okay? I know you were. I know you were thinking that. I thought that when I was in this class. Anyway. Okay. So, x log of 5 minus x log of 4. I forgot the x. And now it's ugly.
She'll erase here in a minute.
Coach, you got any kind of explanation on how it wouldn't be some kind of 1?
They're not like terms.
You just think they are. They ain't.
Okay? And we are literally 2 steps away here. How do I get that x by itself? Not distribute, factor. They both have an x, right?
Oh, God.
So I can move that x out front, and I'll have a log of 5 minus a log of 4 equals 3 log. That does not equal log of 1 either.
No, it equals
Everybody wants it to, but it doesn't.
Tell them, Coach, it equals 3 log
All right.
of 4.
And what's my last step?
Distribute.
If I distribute, I'll be right back to here. I want it to get rid of it, so I'm going to divide. Now, there was that day the other day that you...
The other day, that one time?
That one time. And finally, we have x by itself, and we put all that in our calculator. Make sure that you use your pretty little parentheses buttons on that bottom. Otherwise, your calculator will divide it by log of 5 and then subtract log of 4 rather than dividing it by.
And then you would get 1.
And you get the wrong. You don't get 1. I don't know what you get actually, but it's not the right answer. Whatever you get.
Coach, how many of those was ever on the test?
Not too many.
There's about 4 or 5 of them, probably.
Probably about 10.
Maybe something like it.
It's like 2 probably. Not 2.
18.6377 is what my calculator in the book gave me. Is that what y'all got using your actual calculator? Okay.
Question 9, this is one of the lessons that like I this like chapter. So this class is going and I'm
Logs are
not just
fun.
sit here like
Logs are fun.
like
All right, let's do another one. That was lots of fun. 43. 0.16 to the x. Excuse me, that is wrong.
Damn.
To the 4 plus 3x equals 0.3 to the 8 minus x. Okay?
Coach, have you watched the Survivor season?
Never even heard of it.
Survivor? Been on for 20 years. How would you know?
Well, I've only been around for 16, man.
I mean, I've watched it, I just haven't watched it on Netflix.
They put one of the like newer seasons on Netflix.
Gotcha. All right. What do we do first to each side? Take the log. And by the way, okay. Well, I'm glad you said that. I am glad you said that, okay? She just took the words out of my mouth. You will get tired of writing logs. So what you can do is you can skip a few steps, okay? Just foresee into the future, what are we going to do with this after we write log down?
We're going to move that sucker to the front.
We're going to move it to the front. So go ahead and do that all in one step, okay? So you can go ahead and put, all right, that's going to be 4 plus 3x times log of 0.16 equals 8 minus x times log of 0.3. Okay, so we skipped a step there. All right, but you know, it saves us writing it logs, you know, a couple times at least.
I think you can write it on one of the problems.
Oh my god,
It's just a One time I made the
Distributes.
Oh, yeah. Let's distribute stuff.
my dyslexia.
Distribute on the right side as well. 8 log of 0.3 minus x log of 0.3.
I just so happy we're on the room here.
All right.
Equal.
What do we need to move?
Wait, I'm still writing.
We need to get the x logs on one side and the not x logs on the other. So I'm going to move this x log on the end to here, plus x log of 0.3, plus x log of 0.3.
Wait, so
Okay?
you can add them together, but you can't subtract them.
I haven't added them yet.
Okay.
No, I can't add them.
You can't add them?
Nope, because again, they're not what?
Same base.
They're not the same thing, okay? I'm going to move the 4 log of 0.6 or 1/6 to the right,
It's going to be fun.
and it's gone from over here. And now, again, to save time, I can't subtract these, but what am I going to do with that x?
Should be.
I'm going to pull it out. So rather than writing this again and then writing it again, I'm going to go ahead and factor this x out. I'm going to put x, and I'm going to have 3 log of 0.16 plus log of 0.3 equals, over here, you don't have to pull anything out. You can write it just like it is. Eight log 0.3 minus 4 log 0.6. And now we have one more step. Divide by all of that.
whole thing.
The entire thing. It would be nice. And I was about to say it would be nice if we could add these together. We can add this bottom part together, but the problem with doing that, Clayton, is when you do it in your calculator, it's going to give you a big long decimal, and you never want to round until your final answer. So you would do it, and then you would round that answer, and then use it and keep rounding. So you just want to leave it like that and just plug it all in at once. Okay, yes. So these cancel. X equals 43 is, no, they're saying it's 0.3434. Okay.
I trust you, Chase. I'll write that one. C4 block, coach.
My legs hurt today. Did yours?
Oh,
Dude, the
that's
amount of
killing
times
me.
I
Coach,
said,
your legs hurt?
He knows. He does the deck of cards with his actor. And that is way worse than what we did
oh,
back
I
then.
hate this
No, we don't do circuits. I have done them. They ain't
I will.
deck of cards. I would do 20 circuits in a row before I did the deck of cards.
No, not after Monday's workout.
Tell you.
Monday's workouts, then circuits, then yesterday's.
Coach Knight, he don't know, does he? He just don't get it.
What is the deck?
It's no weight. It's all body weight. And it is the worst thing
They're
you will ever
awful.
All right.
We have to do them in days.
What do y'all think on this one? I got good
Come
news.
on, let's keep mouth shut.
It don't take as long. Do we need to take log on both sides? No, it's already got a log, right?
Yeah.
So it's kind of already done that step for us. We just need to move that x. Can we move the x?
Of course.
Where can we move it? To the front.
I want to see it too.
So that will be 0.25 equals x log of 16. One more step. Tell me. Give it to me. Divide by log of 16. Great job.
You guys are amazing.
Put that in your calculator and you get 0.2076. That's much quicker. You only had to write log twice. There you go. All right, so 47. We need to use our change of base formula here. So that would make it log of 6 divided by log of x is greater than 1. Okay.
Yes.
And then we're going to move this log of x over here by what? Multiplying log of x on both sides.
Well, oh, that was slick. I saw it, Coach. That was slick.
So we get log of 6 is greater than log of x. Therefore, 6 has to be greater than x.
Still wrong. Oh,
No.
never mind.
Good. All right.
Well, coach.
You see what he did?
Oh.
Instead of like multiplying 1 times log of x, he just wrote OG x after the 1.
That is sweet.
Oh, yeah.
Why do scabs itch? That's what my scabs itch.
That's not I don't think that's my scabs don't. I don't think that's what it is.
He's just like, I got to walk with. I had a bunch of like turkey by
All right. You also, for this one, y'all listen. I was just looking at the answer. The answer actually in the back says it's 1 is less than x is less than 6. So let's talk about.
Wait, what?
I'm going to show you. You can't have a negative here. And apparently, the log of x, the log of 1, see what the log of 1 is.
0.
It's 0. So anything less than 1, your answer is going to be negative. Okay? And it's not going to be negative. Okay? It can't be negative. So, don't freak out. You won't have one like this on your test. Okay? It has to be greater than 1, but less than 6. It's got to be in between 1 and 6.
I understand.
Okay? Otherwise, your log would be negative. Okay? All right. The bell is close, so let's see here.
We just didn't do the last two problems.
Let's just skip to 51.
Hey, kid.
Is that okay?
This
So we are not doing it.
You do not have to do 49. I'm sorry.
It ain't no kid.
It might come be.
No, she just said that. I thought that Kate. Sorry, she was mean to me yesterday, so I had to be mean to her, but I didn't know.
I was not mean.
Well, she did.
You told me I better get used to it.
That was funny though.
Log base 3 of what? 52.7. We're skipping 49, going to 51. All right? So, very, very similar to the other one. There's really not any work to do except put it in your calculator on this one. Log of 52.7 over log of 3, or you can use your log base button and just do it all at once. There's no equal to. I don't know why I put equal to there. It's just sticking it in your calculator, and you should get 3.6087.
That sounds like
All right.
a plan there.
What time that is?
Y'all have a great night. See you next time, and as always, stay above the line.